now that we have a sense of how matrix multiplication works, let's see how we can apply matrix multiplication in the real world. So in this first example, I'll show my thought process in terms of how I go about constructing a matrix multiplication problem for a scenario. So here we're told that there are fruit smoothies and nutritional contents, and a tropical fruit smoothie is made from 2 cups of chopped mango, 1 cup of pineapple, 1 cup of coconut, and 2 cups of ice. So that's our first smoothie. Then we have a second smoothie, which is a pina colada smoothie, and that's made from 2 cups of pineapple, 1 cup of coconut, and 2 cups of ice. So we see we have 2 smoothies, and we have a certain amount of ingredients in each of these. Then we're told how much each piece of fruit or each ingredient has in calcium and vitamin C. So a cup of fresh mango contains 10 milligrams of calcium, 27.7 milligrams of vitamin C, and fiber, and 1.8 grams of fiber. Then we're told a cup of fresh pineapple contains 7 milligrams of calcium, 15.4 milligrams of vitamin C, and 1.2 grams of fiber. And then a cup of raw coconut contains 14 milligrams of calcium, 3.3 milligrams of vitamin C, and 9 grams of fiber. Now we also have this ingredient of cups of ice, and ice is frozen water. It has no specific nutritional content as far as, well, perhaps it does, but we probably agree it's pretty negligible in terms of the amount of calcium, vitamin C, and fiber. At least we're going to assume that. So first I might choose for this first block to construct maybe a table or a matrix-like object. And there are a number of ways we can go about this, but we have 2 smoothies and we have mango, pineapple, coconut, ice. We have 4 ingredients. So we can construct a 2x4 matrix where we might have the 2 smoothies. So I'll call this the tropical fruit smoothie, TFS, and a PCS, pina colada smoothie. And then I will list the ingredients. And the ingredients are mango, pineapple, coconut, ice. So mango, pineapple, coconut, and ice. And this is a 2x4 matrix. We could also make this a 4x2 matrix where we have, instead of the smoothies along the rows, we could have our tropical fruit smoothie and our pina colada smoothie like this: mango, pineapple, coconut, and ice. Now, we want to determine how much nutritional content each smoothie has. Now, the nutrition is going to come from these calcium, vitamin C, and fiber. So we're going to need, for each of the 2 smoothies in the end, we're going to want to know something like this. We're going to want to say, in the tropical fruit smoothie and the pina colada smoothie, how much calcium, vitamin C, and fiber do we have in those 2 smoothies? So we could either end up with an answer that contains 2 rows and 3 columns, or, of course, depending on how we design this, we could also have our smoothies on top along the columns and our 3 nutritional units as the rows. In that case, this would be a 3x2. Now, it's tempting to want to just calculate things and multiply things out by hand, but it turns out it's much more efficient to do this with matrices, especially if these matrices were large and there were way more smoothies and way more nutritional facts that we wanted to keep track of. So this is kind of our end game. I'll call this our end game of what we want to come up with. And we also need to construct some sort of matrix for this second block here of information. And there's a couple of different ways we could do that. We have mango, pineapple, coconut. We also have ice. If we want, we can make ice negligible since it doesn't have any nutritional content, but I'll go ahead and include it here just so that our problem is complete. So we have a couple of different options. We could have our fresh mango, then our pineapple, then our coconut. Just to be consistent here, I'll just label this M instead of FM for mango. And then we have ice. And then I could list out the nutritional contents for each of those in terms of calcium, vitamin C, and fiber. And that would give me a 4x3 matrix. Or we could make this a 3x4 matrix and have calcium, vitamin C, fiber listed here, and then mango, pineapple, coconut, and ice listed here. And that would give us the 3x4 matrix. So let's fill these in. Turns out we only really need to do one within each of the two blocks, the two paragraphs. And the first one, tropical fruit smoothie, now we just need to list it out, has 2 cups of mango, 1 cup of pineapple, 1 cup of coconut, and 2 cups of ice. So this is the number of cups. I'll keep that in mind. Pina colada smoothie has no mango. It doesn't mention anything about mango, so it has no mango. 2 cups of pineapple, 1 cup of coconut, and 2 cups of ice. Now, if we just transpose that matrix, this is called the transpose of that same matrix, but the rows are columns, the columns are the rows. And so the first column, instead of being the first row, would be 2, 1, 1, 2. And the second column would be 0, 2, 1, 2. We'll do the same thing for the second situation here for our nutritional intakes. A cup of fresh mango contains 10 calcium. Okay, this is milligrams. And this is milligrams per cup. I'm going to point that out. This is milligrams per cup. It has 27.7 milligrams of vitamin C per cup. And fiber has 1.8 grams of fiber per cup. Notice the unit difference there. It's not going to matter because we can't add calcium, vitamin C, and fiber together anyway, so it doesn't matter that even if they were all different units, we wouldn't want to combine them into one, because you can't add those 3 different nutritional contents together and get a single value that makes sense. Now, pineapple has 7, 15.4, 1.2. Coconut has 14, 3.3, and 9. And then ice has nothing, and so this row is going to be all zeros. Now, once again, this would be the transpose of that matrix had we written it as a 3x4 instead. And the first row would be the same as the first column here, since that's calcium. 10, 7, 14, 0. 27.7, 15.4, 3.3, and 0. And then 1.8, 1.2, 9, and 0. And so just to kind of make this visually clear, the columns became our rows, the rows became our columns. So you can see that the first column here, 10, 27.7, 1.8, is the same as what was the first row right here. So it's just all about how we write it. Now, one thing that I do want to keep consistent is notice how we've listed the ingredients in the same order. The one key piece that's similar between the 2 sets of matrices is mango, pineapple, coconut, ice. Mango, pineapple, coconut, ice. We don't want to reorder those because then when we multiply them, we won't be multiplying facts about mango with facts about mango. Now, I see that what I could do is if I choose the 2x4, then the multiplication with a 3x4 won't make sense. The inner dimensions have to match. 4 doesn't match 3, so I can't multiply those. But I can multiply a 2x4 with a 4x3. 2x4 with a 4x3. So if I look at what that would give me, if I take a 2x4 times a 4x3, let me go ahead and list these out just one more time. 2, 1, 1, 2, 0, 2, 1, 2. And I multiplied that by 10, 7, 14, 0, 27.7, 15.4, 3.3, 0, 1.8, 1.2, 9, and 0. So I have a 2x4 with a 4x3. Now notice that the 4 here corresponds to the 4 columns mango, pineapple, coconut, ice. And the 4 here corresponds again to mango, pineapple, coconut, ice. So if I multiply these two matrices, I want to make sure that I'm multiplying the number of, this would be the number of units of calcium per cup of mango times the number of cups of mango in each of our two smoothies, TFS and PCS. And then this represents calcium, vitamin C, and fiber. Okay, multiplying these together, it's going to be a bit of work here, but it'll be 10 times 20 plus 7 times 12 plus 14 times 11 plus 0 times 22. Now let's think about what these mean. This 10 is the number of grams per cup of calcium, and 20 are the number of cups of each of those 4 ingredients in our fruit smoothie. 7 represents the number of calories, grams of calcium per cup of pineapple times the number of cups of pineapple in each of those 2 smoothies. Again, I have grams per cup of calcium in a coconut cup times the number of cups of coconut. And so I'm adding basically grams plus grams plus grams plus grams, and this will strictly be for calcium. Then I'll repeat the same thing, but now it's just going to be for vitamin C. It's going to be each of those 4 scalars multiplying those columns. And then plus 0 times 2. Now notice ice always gets zeroed out because it doesn't have any nutritional content. And then lastly, we're going to do fiber. So that was vitamin C, and this is fiber. Now the rows, we're going to have 2 rows, and those rows, notice, are still tropical fruit smoothie and pina colada smoothie, since that's the number of cups in each of those 2 smoothies for the 2 components of our vectors. So now I'll have 1.8 times 20 plus 1.2 times 12 plus 9 times 11 plus 0 times 22. So you see we could have ignored the cups of ice altogether. Since there's no nutritional content, it would have really just saved us this last term here. So let's produce the result. Okay, here's our result written out, and once again, this is for tropical fruit smoothie, this is for pina colada smoothie, and this corresponds to the calories, I keep saying calories, calcium, vitamin C, and fiber. So that means that a tropical fruit smoothie has in total 41 milligrams of calcium. I think I wrote grams over here. These should have been milligrams. 74.1 milligrams of vitamin C and 13.8 grams of fiber. Then, I'll put the units here as well just for reference so I don't make that mistake. And then a pina colada smoothie only has 28 milligrams of calcium, 34.1 milligrams of vitamin C, and 11.4 grams of fiber. So one of the things that I really want you to notice here as you're doing this is not only do the dimensions of the outside end up being the dimensions of our final matrix, which is 2 by 3, but we should also point out that the labels along the rows are the same as the labels along the rows in our final product, and the labels of the columns are the same as the labels of the columns in our final product. As well as, notice the consistency here. Not only do these inner dimensions match, but also what we're comparing, what we're multiplying are like parameters. Mango, pineapple, coconut, ice times mango, pineapple, coconut, ice. That's very important in order to do that. Now you can just verify. Back up here, we constructed two different sets of two matrices each. If I had gone with the 4 by 2, then in order to have something to multiply it with, I can't do a 4 by 2 times a 4 by 3, and I can't do a 4 by 2 times a 3 by 4, but I can do a 3 by 4 times a 4 by 2, which would give me, since the inner dimensions match, a 3 by 2 matrix, which would give me the same information as this one. It would just be the transpose of it. It would have calcium, vitamin C, fiber, tropical fruit smoothie, pina colada smoothie, and then our 6 values that we came up with, just the rows being the columns instead. So there are two different ways we could go about doing this problem, and you can see that we chose to have our nutritional facts along the columns, our smoothies along the rows. Now this is not the only application of matrix multiplication. We can actually use it to make sense of data. So the 2011 U.S. Statistical Abstract reports a survey in which they compared different age groups, under 25, 25 to 34, 35 to 44, and the amount of money they spend on event, fees, and admission, audio and visual media and equipment, and reading materials such as books, newspapers, and magazines. You can see not much on fees and admission, audio, visual, everybody kind of spends a lot of money there, and then nobody really spends very much on reading. And this gives us the average of this data is summarized in the table below. So on average, somebody who's under 25 spends $271 per year on fees and admissions, $681 on average on audio visual, so maybe online streaming services, and $48 per year on reading materials. And you can see that those kind of all step up. As people get older, they'll probably have more money to spend on these different things. Now, what can we do with matrix multiplication? Well, I'm going to argue that if we multiply this 3 by 3 matrix by this 3 by 2 matrix, we're going to get two pieces of information. The first one being the average spending across all age groups for each of the 3 categories. In other words, if I want to know on average how much do people from 0 to 44 spend on fees and admission, assuming they're the same number of people in each age group, then I can calculate the sum of these 3 values divided by 3. I can do the same thing for audio visual. Add up 681, 1105, 1168, divide by 3. Same thing for reading. And you can see that there's a 1/3 in that column. The second piece of information that we'll get when we multiply by this is how much more or less the 35 to 44-year-old age group spends than the under 25-year-old age group on each of the 3 categories. So let's see how that works out. So we'll have 271. Well, I'm not going to list it again. I'll just write my matrix up here. So we'll write 1/3, 1/3, 1/3, -1, 0, 1. And as we know, when we multiply, we're going to take 1/3 times the first column. So 1/3 times 271, 681, 48, plus 1/3 of the second column, 524, 1105, 79, plus 1/3 of the third column, 823, 1168, 102. Now we're done with that column, so we'll have a second column in here. And that second column will be -1 times the first column plus 0 times the second column. Now, because the second column is going to get multiplied by 0, essentially we don't need to worry about that term in there because those components are going to get scaled by 0. They will all be 0. So it's really meaningfully only the -1 times the first column plus 1 times the third column. Now, I'm not going to actually compute this, but I want to just illustrate that these 1/3, what they'll do is average across the 3 age groups. And if I take 1/3 of 271 plus 1/3 of 524 plus 1/3 of 823, that's the same thing as adding the numerators and putting the whole thing over 3. So that first row in the first column will consist of the sum of the 3 values all divided by 3. Same thing as taking 1/3 of each value. The second component will be 681 plus 1105 plus 1168 all over 3. And the third element will be 48 plus 79 plus 102 all over 3. Now that's just going to be my first column, and so these are averages for, again, notice that fees and admissions, audiovisual, reading, now these don't have units, right? Because they're just what we call, this is just called a dummy matrix. It's kind of a funny term, but dummy matrix just means it just serves a mechanical purpose. They don't have any units, and unitless values are sometimes called dummy values or dummy variables. But what we have to remember is that this is still fees and admissions. This is audio visual, and this is reading down here. This is going to give me the average across all the 3 age groups. And now here we're arguing that also we'll get how much more or less the 35 to 44-year-old age group spends than the under 25-year-old age group. Well, the way we could see that is this -1 times 271 plus 1 times 823 is the same thing as 823 times 1, which is 823, plus -1 times 271, which is -271. So notice that it's just going to be the difference between that value and that value, and 823, just as an example, 823 minus 271 is $552. So on average, a 35 to 44-year-old spends $552 more per year on fees and admissions than does an under 25-year-old. Well, what about the 25 to 34-year-olds? Well, that zero scalar allowed us to effectively ignore the second column. Now, we didn't ignore it. We still multiplied it by something, but it didn't affect the final result. In our second row, we'll get, by the same logic, 1168 minus 681. So we can see that 35 to 44-year-olds is going to be a positive number. They spend more than 25-year-olds. And same thing in the third category of reading. And this is the difference between 35 to 44 and under 25. And so that multiplication really just served a mechanical purpose to summarize our data for us.